Aloha and welcome to our video on the solar system. In this video, we'll look at the differences between terrestrial and Jovian planets, and we'll also explain how the solar system formed. In this picture, we're taking a look at the solar system as an entirety per se. And what I want you to do is I want you to realize we have a heliocentric model, so our sun's here in the middle. We then have our 4 terrestrial planets, that would be Mercury, Venus, Earth, and Mars. And then beyond that, we have the asteroid belt. Beyond that, we have our 4 Jovian planets, which would be Jupiter, Saturn, Uranus, and Neptune. And then we have our dwarf planet of Pluto. And we'll be talking in the upcoming videos about these different planets, but let's take a look at some basic facts here real quickly. So in this slide, we have a picture. Remember, we have our 4 terrestrial planets here, and then we have our 4 Jovian planets here. Pluto is a dwarf planet, but a lot of times it's kept in the loop of the planets, so we can use it as a comparison against other things. As we look at our planets in the chart here, some of the things you'll notice, we have the known satellites. That's as of 2006. So we'll see that we have 1 around Earth, the moon. We have 2 around Mars. Then we have 63 at Jupiter, 56 on Saturn, 27 on Uranus, and 13 on Neptune. Pluto has so many because it hasn't completely cleared the orbital field, so we see some debris there. So we can kind of see a little bit of differences there as well. We'll talk about the planets a little bit more. They'll cover them in the lesson, so I don't want to spend a lot of time going through the rest of the data. But you can kind of see how long it takes it to go around the sun, how long does it take it to rotate on its axis, and then we can kind of look at the sizes relative to Earth here. So how did the solar system form? Well, we believe in the Nebular Hypothesis, and what that means is that we had a nebula, or a cloud of gas and dust that was out in space, and we started to have some coalescence in the center of this. So we'd have gravity taking place, and it would pull together, make larger pieces, more gravity, pull together more pieces, and that nebula would rotate in time as well. So we see a little bit of this rotating gas cloud. And what we're going to notice is here in the middle is where we're going to have the formation of our star, and that's going to be the sun. So as we look here, we're seeing the formation of the sun here, and we have the remnants of this nebula are still going to be flattened out into a disk. They're going to be rotating in that. And as they're rotating, they're going to bump into other pieces, and we're going to have that gravity occurring, and we'll form what we call planetesimals. And planetesimals are going to be these larger particles still traveling in a disk-like area. They'll start to congeal into these rings, which are our orbital rings here. And we'll see this process go until we actually have the formation of planets. So if we get one slide with all of this, we can start with our nebula here. We start down, we form our protostar. Once we have our star formation here, we have our leftover material in this flattened out disk shape that's going to start coalescing into planetesimals, which you can kind of see here, just larger bodies going around. And then once they clear that orbital path, then we end up with our solar system here. And we'll talk about the different pieces and parts in future videos. As always, good luck with your quiz, and we will see you in the next video.